Hi, you guys. This video is going to start the lesson on inverse functions. So if you want to go to page 27 of your packet, you will find the page that I'm on. I started with writing down, it's not really the definition of an inverse, but it's more like things that are true about inverse functions. That's a little bit better way to write this. So if you want to take a minute to chat or to jot those down, go ahead. I'm going to read through them and then I am going to continue. So inverse functions are functions that have the domain and range switched. The x and the y values of the points are interchanged. If you look at these graphically, the inverse functions are reflections over the line y equals x. And the last thing that is true is that when you compose a function with its inverse and you simplify it, you get x. So that's where the f of f inverse of x equals x, and vice versa is also true. Those are things that are true about functions. Today that's not really going to play a part in it. I will say out of all of the things today, we will be using the fact that the x and the y's are switched. This lesson is going to cover 2 days. We're going to work on it today, and then we're going to also work on it the next time I see you. But you do want to make sure that you are taking notes on, watch both of these videos. There will be 2 videos. All right, so example 1 is talking about finding the inverse mathematically. Verify that the inverses are of each other algebraically. We're not going to do that part. We are going to find the domain and range of the original and the inverse. I guess we're using that a little bit too, so we're using this other idea up here. All right, so how do you find an inverse? Basically what you do to find an inverse is you switch x and y, and then you solve for y. And this again is review. So one thing I want you to know is whenever you have an f of x, that means the same thing as y. So I am going to switch the x and the y. So I'm going to make this x equals 3/2 y plus 1. I am going to solve for y now. So in order to solve for y, I would subtract 1 from both sides. That would leave me with x minus 1 equals 3/2 y. In order to get the y by itself, I'm going to multiply by the reciprocal of 2/3. Remember, you're multiplying the entire side by 2/3. So over here, I end up with y equals 2/3 times the quantity of x minus 1. You're welcome to distribute this. I'm just going to kind of leave it. Actually, no, I'm not. I'm going to distribute it. But what I want you to know is that it's not really what y equals. It's called the inverse. And the inverse notation is f with this little -1 of x. So f inverse of x is 2/3 x minus 2/3. I want you to notice here that that is a line. That's the answer of finding the inverse. The domain of this line, of any line, is -infinity to infinity, and the range is also -infinity to infinity. I want you to go back and look at the original. It was also a line. So that domain is -infinity to infinity, and the range is also -infinity to infinity. What you cannot tell here is that what's actually happening is the domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse. You can't really see that here because it's just a line and everything's -infinity to infinity. I'm going to skip B, but I am going to go ahead and go down and do C, just because this one's a little bit different. This is a cubic graph. If you actually plug that into the graphing calculator, or it's not a cubic, I'm sorry, it's a cube root. So if you type this into your graphing calculator, you might want to do it. It's kind of cool looking. I'm going to do it real quick. And you hit graph. It ends up looking like, it ends up looking something kind of like this. This is the original graph. It is shifted left 1 and down 4. Kind of looks something like this. The domain of that is -infinity to infinity, and the range is the same. So this is another one where you're not going to really notice the change, but I just thought I would show you. So that's my original graph, but now I need to find the inverse. So in order to find the inverse, I need to switch x and y. And remember, y is the same thing as f of x. So I'm going to switch those spots. X equals the cube root of y plus 1 minus 4. And now I'm going to solve for y. So I'm going to add 4 to both sides. That gives me x plus 4 equals the cube root of y plus 1. In order to solve for y, I need to get rid of this cube root. In order to do that, you cube both sides. Now, I don't want you to actually cube it on the left. I want you to just leave it as x plus 4 quantity cubed. On the left, the cube and the cube root cancel each other out. You're left with y plus 1. And then I want you to subtract 1. And remember, that's not really what y equals. It's what f inverse of x equals. And that is x plus 4 cubed minus 1. Well, if you think about what that graph looks like, that's a cubic graph shifted 4 to the left and down 1, and it kind of looks like this. So what is hard to see in this is if you actually put this into your graphing calculator and you typed in the line y equals x, this ends up being a reflection over that. But the domain of the inverse is negative infinity to infinity, and the range of the inverse is also negative infinity to infinity. Again, hard to see what's happening, but what's actually happening is the domain of this one becomes the range of the inverse. The range of the original becomes the domain of the inverse. Now I'm going to do the last one here, and that's probably the most difficult one of the whole thing. I need a little bit of space, so I'm going to erase this. If you need to rewatch it, just rewind. Alrighty, now I'm going to do D, and D is probably the most challenging one on this whole page. Again, we're going to switch x and y and solve for y. Not going to do that part quite yet. What I want to do is show you that if you plug this into your graphing calculator and you take a look at it, it ends up looking something kind of like this. There is a vertical asymptote here at -3. There is a horizontal asymptote at 4. And the graph looks something kind of like this. It's a rational function. So the domain here is negative infinity to -3 and -3 to infinity. The range is negative infinity up to 4, that horizontal asymptote, and 4 to infinity. Just a quick reminder on how to find these. The vertical asymptote is found by setting the denominator equal to 0. If you solve that you would get x equals -3. I meant to say the vertical asymptote. I don't know what I said. I think I said horizontal. That's to find the vertical. To find the horizontal asymptote, you look at the degree. And the degree is the highest power of x. These degrees are both 1. And so then the equation is y equals 8 divided by 2. So y equals 4, which is where that comes from. Again, that's a review from last year. But I want to point out that we are going to see these domains and range actually switch once we do the math. So now what I need to do is I need to switch x and y and solve for y. So remember, this is a y. I need to switch it to both of those x's. So this is going to be x equals 8y minus 4 over 2y plus 6. This is where it gets fun. We need to solve this for y. So you guys could actually pause the video and try to do it yourself right now. I think that's kind of a fun idea. If you don't want to do that, that's fine too. What I am going to do here to solve this is I'm going to first multiply both sides by 2y plus 6. Sorry, this is in my way. And that's going to get rid of the fraction part of it. And I'm also going to distribute this through this x. So that's going to be 2xy plus 6x equals 8y minus 4. And now you need to look at that and you need to think, okay, I need to solve for y. The issue is that the y's are on opposite sides right now. So what I want to do is get all the y's on one side and everything else on the other. So what I am going to do is I am going to subtract 8y over here. That's going to give me 2xy minus 8y. I do have this plus 6x, but I'm going to subtract 6x from both sides. So I'm kind of doing like two steps in one. That gives me negative 6x minus 4. Someone's printing something at my house, so sorry if that's making too much noise. My printer's right here. Then what's so cool about this is you have all the y's on one side, except there are two of them. So I need you to think about how we're going to make it into one. And what you do is you factor out that y. And when you factor out the y, it makes it occur only one time. And then you can easily solve for y by dividing by 2x minus 8. And so then you end up getting y equals, except remember it's not y equals, it's f inverse of x equals negative 6x minus 4 over 2x minus 8. And that is the inverse of that one. And now watch this. The domain, remember I said, comes from setting that denominator equal to 0. Well, if you set that equal to 0, you get x equals 4, which means the inverse has a vertical asymptote at 4, which means that the domain would be negative infinity to 4, union 4 to infinity. And the range is the horizontal asymptote, and that comes from the degrees. The degree of the numerator and the denominator is equal. So you divide negative 6 by 2, the leading coefficients, and you get y equals negative 3. So that's the horizontal asymptote, which affects the range. Negative infinity to negative 3, union negative 3 to infinity. And this one's super cool because you can actually really see this happening here. Let me use a different color. The domain of the original became the range of the inverse. The range of the original becomes the domain of the inverse. So feel free to watch that again if you need to see it, but that's how you do all of those. There is one other video, so please make sure you watch that too. Thank you.